Okay, we're just going to continue evaluating some trig functions. In this case, it's the sine of 45 times the cosine of 45. So what we want to do is evaluate this first, write this down, then write this value down and multiply our answers together. So let's go to our unit circle. What is the sine of 45 degrees? So we locate 45 degrees over here, which is going to be this. The sine is the what value? Y value by our definition. So what's our Y value? Square root of 2 over 2. Great. Alright, and I want to multiply that by, now let's go to find the cosine of 45, which just so happens to be that same location. Cosine of theta is equal to x value, so we just get square root of 2 over 2. Now we just do the algebra. It says now multiply those two together. So our square root times the square root is just 2. And then 2 times 2 on the bottom is just 4. This is just going to simplify to 1/2. Okay, our next one is the sine of 90 plus tangent of 45. So first of all, we want to evaluate sine at 90 degrees. It's the y value, which is going to be 1. Tangent at 45 degrees, so we come over here to 45 degrees. What's the tangent defined to be? Tangent theta is equal to the y over x, but what's the same thing divided by the same thing? Just simplifies to just 1, so that's pretty nice. And then we just algebraically simplify this to be 2. Secant of pi fourths times the cotangent of pi fourths. Okay. So you can remember this by the definition as the secant is 1 over the x value, and cotangent is 1 over your, it's your x over your y. So go work those. 1 over the square root of 2 over 2, which then, this is the secant of pi fourths. If I rationalize, I'll multiply by the reciprocal first. 2 over the square root of 2. So then that would just be 2 over the square root of 2. But what do we want to go ahead and rationalize this. So times the square root of 2, this is an extra algebra step, would be 2 square root of 2 over the square root times the square root is just this. And then we can see that these two cancel, so that just simplifies to the square root of 2. So I'm going to erase all that algebra and put the square root of 2. Square root of 2. That's the secant of pi fourths. Now the cotangent of pi fourths is going to be your x over your y of, 45? Which this one's easy because this value over this value, it's the same thing. So when it simplifies, it's just going to be 1. And then we multiply those two together to get our final answer to be the square root of 2. Okay, we have our next two examples. If you want to write them down, pause them, try to work them, and then check your work. On this first one, the algebra is a little bit tedious, but the trig part's not too bad. Cosecant is 1 over y, so that's 1 over the y value. I'm now multiplying by the reciprocal. Then this cancels, and I'm left with 2 over the square root of 2. Okay, and then I need to rationalize, which is, we just did this one, so we should have an idea of where this is going. Just simplifies to the square root of 2. So cosecant of 45 is the square root of 2. Tangent of 60, we're going to work it and get that one next. So the tangent is going to be your y over your x at 60 degrees. So it's your square root of 3 over 2 divided by 1/2. Yeah. Okay, now let's do the algebra. Let's multiply by the reciprocal. 2/1, multiply by the reciprocal, and multiply straight across and we get the square root of 3/1, which is just the square root of 3. So this was all of our work for cosecant of 45, simplified to square root of 2. This was all of our scratch work for tangent of 60, square root of 3. Multiply those together for our answer, which is a square root of 6. Okay, next we're going to start with tangent of 45. We like this one because it ends up being the y value over the x value. When they're the same, it's this divided by this, which just simplifies to 1. Cosine of 30 is going to be the square root of 3/2 because it's cosine of theta is equal to x. So that's a fairly easy one right there, square root of 3/2. We multiply those together and our solution is square root of 3/2 as our final answer. Okay, this next part is just a calculator section, like using our calculator to approximate values of trig functions. Now you will notice on your calculator you have a sine, cosine, and tangent button. You have those buttons, but you do not have the secant, the cosecant, or cotangent. What you have to imply is that the secant is the reciprocal of the cosine, and remember my trick for that is the SC flip order. And those two are reciprocals. Then tangent and cotangent, they're easy to remember because they both have t's, and then the only one are the other two that are left. So reciprocal wise, in our calculator, we only have sine, cosine, and tangent buttons. So if I need to evaluate a secant function, I would put 1 over the cosine of theta. So that's kind of how we're going to use the 3 buttons on the calculator to be able to figure out some that are possibly may not be on the calculator. So this is just practice on your calculator. The first example is if I ask you to key in the cosine of 48 degrees. I want you to plug that in on your calculator, find it, cosine of 48, and approximate, let's do 2 decimal places. So it's like 0.6691306. We're going to say is approximately 0.67. Make sure your calculator is in degree mode because we're working with degrees. So let's just see one example. What if I say the cosecant of 21 degrees? Now, what's the first thing you notice? You say, well, they don't have a cosecant button. And I say, you're exactly right. So we have to do, to calculate it, we'll have to do 1 divided by the reciprocal of that, which is sine of 21. So you'll put that information in your calculator and round to 2 decimal places. It came out to like 2.7904. Keep going. So I'm going to say is approximately 2.79. Okay. Now we have an example of tangent of pi 12ths. We have the tan button, so hit your tan button, parenthesis, find the actual pi button on your calculator, which you'll have to do. Mine is second by the caret button, near clear, but I have a TI 84 plus. You might have to use your second button. All calculators are different, but find pi, divide by 12, close the parenthesis, and you hit enter, and I got about 0.26794 dot dot dot. Keep going. We're going to round that approximation to a point, approximately 0.27. Okay. Okay, so when you check this, if you still had your calculator in degree mode from working these other things, this one is in radian mode, right? This is a radian. It needs to be in radian mode. So if you didn't have the right calculation there, when we went to radians, you should go to your, mine is second mode. just there's a mode button. So hit your mode button and you should have a place where you can change from radian to degree mode and interchange back and forth. So make sure when you're working with radians in radian mode, as well as this next example, like when you have secant of 1, that's not a degree right there. If I don't have a degree, we need to use radian mode. So in this case, I don't have a secant button, so I'm going to have to do what? 1 over the cosine of 1. And while this is in radian mode, it's approximately 1.85. Likewise with this. There's not a degree up here. That means we're going to assume radian mode. And tangent we calculate, so just hit tangent of 1 and we will get approximately 1.56. So that's just some practice with your calculator and putting trig functions in. And that should wrap up our information for today.